everyone. So, my name is Malvika Gupta. Now, we are going to discuss one more partition algorithm for quick sort, and this is Lomuto partition. Okay, so this is almost similar to knife partition, which we have already discussed in the previous video. Here also, I'm not going to talk about that what is how we will be going to perform the quicksort algorithm, because quicksort algorithm I'll be creating a new video for that. But in this particular video, we'll be only discussing about the concept of how Lomuto partition works, and this is the partition algorithm which we generally use. So the name is Lomuto. So I've already discussed in that video that we have three types of partition. One is knife partition, Lomuto partition, and host partition. And these partitions are important just because we have to find out whichever partition algorithm we do have. We can say that, yes, this is the stable sorting. By using this particular partition algorithm, we could have the stable sorting. By having this particular partition, we could have in place sorting technique. So this thing. In the earlier video of knife partition, we have already understood that we can do stable sorting using that knife partition, but in place sorting is not possible, right? Now let's see, as this per the discussion, we can, as per the practical approach, we can say that Lomuto partition is not a stable partition. It will not provide you a stable sorting. Okay. But it gives you an in-place sorting. It means that you don't have to you don't have to have some other array to store your partition, the values after the partition, right? Like knife partition, it also considers the last element as your pivot element. As in the knife partition, the last element was the pivot element. In the same way, it is here also. But in the knife partition, it was given that all the smaller elements, then the pivot element has to come on the left hand side, and the greater element should have to come to the right hand side. But here it is not the point. It is just only been said that we will be considering only the pivot element. Okay, that that will be your last element. Fine. Here in this particular video, in this partition, we will be starting like, if suppose my value is I, okay, I am going till here because this I have already considered. So it means this part is my sorted part. I'm not going to touch this part. I have to run my entire array from here to here. It means that I have to run it till h minus 1. Okay, because my higher part is this one, but this has actually been given to me that this is the last element is my pivot element. So I'm there in the naive approach. If you remember, then in the naive approach, it was giving the last element was the part, but I was making all the comparisons using that pivot element. Here I'm not going to use this as pivot. It has been fixed over there. Okay, at last I'll be fixing it. Okay, now what I'm going to do is I will be starting from 0. So my indexing will be starting from I minus 1. Okay, if my condition is satisfying, then I will be keep on increasing the size of my smaller elements, and then I'll be moving into this particular array. Okay, so this is the case of Lomuto partition. In case of Lomuto partition, we will be traversing only once. Okay, as you have seen in that knife partition, we were traversing twice, or you can say thrice also, because once it was for the smaller number, second time it was for the larger number, greater numbers, and then we were copying the entire array elements from the temporary array to the original array, so that we can perform the quick sort, right? So in Lomuto partition, there will be only one traversing. Fine. So this is the introduction of Lomuto partition. Let's begin with the pseudocode, and then I will be explaining you how we are going to perform it using that particular pseudocode. Okay. Now let's suppose I am writing, it's like, because I have to give the position. So Lomuto partition, suppose I have given the name is as L partition. So I'm passing an array. Okay. Suppose an array has been passed, and then there is a lower index and the higher index. Okay, pivot element I'm not going to pass, because just I'm considering that pivot element will be my last element. Okay, so let's begin here. So I am setting that my pivot is my last element. So this will be A of H. Okay, this is fixed. H I will be giving as n minus 1, as you all. Again, I have told you that I am going to set my I as L minus 1 on the lower side, lower minus 1. From minus 1 it will be starting. Okay, second point. And the third point will be I am running a loop which will run from L. Okay, so sorry, I am not going to take. I have taken for a here because I have to increase the size of the window. So I'm taking over here as J index, and it will go till H minus 1 equal to H minus, because all the elements I have to consider. If suppose I have 7 elements, so by default it is going till 6, and I have to sixth is my pivot element. I'm not going to take that particular element into my comparisons and anything. So what I'm going to do, I'm going to run it till H minus 1. Then this J plus plus. Okay. Now the condition arises that if my A of J is less than my pivot, because pivot is also the element, because I have stored the value over here. So what I'm going to do, I'm just going to increase the size, because then I have to put the value and performing a swapping between AI and AJ. Okay, so the values will get swapped. Then ending it, and at last, once it is entirely it is done, then I'm going to swap my A plus I plus 1 position with my A of H. It means my pivot value, and then this is my fourth step, and my fifth step will be I am returning the pivot value, pivot position of my pivot. Okay, so this will return me the position of pivot. Okay, so this is the pseudocode, and let's now run it using an example so that it will be very easy for you to understand that how we are running it. Okay, I'm taking each and every step by step. I'm going to take it. So first of all, let me create an array of suppose 10, 30, 90, 40, and suppose just 70. Okay, this is my array. Okay, so here I'm going to find out the pivot element. So I know that this is going to be my pivot. Okay, so the value of L equals to 0, H equals to 6, and then my pivot is A of 6, which will become 7. Okay, so pivot is 70. Now, first of all, what I'm going to do, let's begin. My first indexing, this is I have set already. So the value of I will be starting from -1, because I was already I equals to L minus 1. I have already told you here that I equals to L minus 1. So it will become 0 minus 1 will become 1 minus 1. Sorry. Fine. Now, next what we have to do, we have to run a loop. Okay, so we are going to run a loop from J equals to L, which is 0, till here. This is the position of my loop. So it will be 5 and J plus plus. Then I'm just writing it over here so that it will be easy for me to make you understand. AJ is less than pivot. Okay, then I'm going to do I plus plus, and I'm going to swap the values of AI, comma AJ. Okay, now let's run this part first of all, then we will see what we get. Okay, now see, 0 is less than equals to 5, condition is true. Now you see AJ is A0. A0 is your 10. So 10 is less than 70. Yes, condition is true. If it is true, then your I will become 0. Okay, and you have to swap A0 to A0. Okay, it means that my value will be here only. 10 will remain here. No change. Okay, because I am making the changes in the same. That we can make, you know, that swapping function you can implement, or you know that how to implement the swap function. You can have a temporary array, temporary variable also you can take, right? So I'm not going to tell you that how you going to do this. You can do it easily. Fine. Now the next one, because we have to run this particular loop. Now the value of J will become 1. 1 is 80. Now 80 is less than 70. Condition is false. It is false. We are not going to enter inside it. So it will remain at the same position. We'll move ahead. J equals to 2. 2 is 30. 30 is less than 70. Yes, condition is true. If it is true, then it means that we have to perform I plus plus. It means I will become 1, and we have to move for swapping. So I, because A of I was there, so I is 1, comma, J is your 2. Right? So A of 1 is what? A of 1 is what? It is 80, and A of 2 is 30. So you can make the changes. I'm writing it over here so that I'll be able to show you the changes. So it will become 10, 30, 80, 90, 40, 50, and 70. This is my pivot 0, 1, 2, 3, 4, and 5. Okay. So this is, I have made the changes. Again, I will be moving. So J will become now 3. 3 is 90. Now my resultant array is this one, right? So 90 is less than 70. Condition is false. I'm not going to make any change. J will become 4. Now 40 is less than 70. Condition is true, right? Condition, when it becomes true, then you have to change the value of I to 2. And this will become swap A of 2 with A of 4. This will be the swapping. So I am going to get this as 10, 30, and 4n. So 40 over here, 90 here, 80 will go here, 50, and then your 70. So this is 0, 1, 2, 3, 4, 5, and 6. Right? This is my pivot. Now J is 5. I have come over here. So when J is 5, so 5 is 50. 50 is less than 70 according to this one. Yes, it is true. So again, you have to do this. This will become 3. So I have to perform swap A of 3, comma, A of 50. 50 means 5, right? So A of 3 is 90, 90, 50. This I have to make the changes. So I'm going to make it 10, 30, 40, 50, 80, and 90. And this is 70. 2, 3, 4, 5, and 6. Right? Now, J will become 6. 6 is less than equals to 5. Condition is false. We have to come out. Now we see that we have one step over here. Swap AI plus 1, comma, A of H. So I'm writing it over here. Swap AI plus 1, comma, A of H. So I, what was the value of I? If you see, last value of I was 3. Okay, so you have to perform swap A of 4 with A of H, means 6. So now you see A of 4 is what? It is 80, and here it is 70. So now if you see that you have to perform this swapping, so 10, 30, 40, 50, 70, 90, and 80. 0, 1, 2, 3, 4, 5, and 6. Now you see 70 has come to this particular position. Okay. And you have to return the value of your pivot, and which is I plus 1, which is 4. So pivot is at 4th position. Now see, this is the advantage of Lomuto. We already, in the naive partition, we already know that yes, whatever the value will come, all the lower values in the pivot will come on the left hand side, and the greater values will go to the right hand side. But if you see in the Lomuto partition, only by having the one traversing, we have got the proper division. Okay. So, and if we are performing a partition, then definitely we can say that yes, quicksort is a divide and conquer type of an algorithm. So if you see, you can see from here that we are making changes in only one array. We are not taking another array. But I don't know about it, that yes, if the values will be present, the multiple values will be there, or duplicate elements will be there, then how it is going to perform, because it is not going to give you the proper and the expected output as we desire, because we know that there is nothing like condition of equal to. Okay, so 70 has reached to its proper position. We are not going to move the 70. So when we are going to apply the quicksort, the same way we have done it in the naive partition, it will be like pivot minus 1. We are not going to move this pivot, and quicksort A, pivot plus 1, and H. This is like this. So this is the Lomoto partition. Generally, we use Lomoto, but that we will decide once we are done with the another partition algorithm, which is called post partition, in the next video. Okay. Thank you.